Imagine for a second, a world totally stripped of literally everything engineered. No paved roads beneath your feet, no smartphone sitting in your pocket, no running water when you turn on a tap. It's almost impossible to picture, isn't it? Well, welcome to this explainer, where we're going to trace the absolutely breathtaking evolution of engineering. We're going on a journey to see how human ingenuity transformed from these solitary sketches on parchment all the way to the invisible digital realities that run our modern lives. So, let's dive right in to the evolution of engineering.
Okay, here's our quick roadmap for today. We'll be covering the visionary renaissance, forging the modern world, coding the lunar landing, the invisible revolution, and finally, shaping tomorrow.
Starting things off with Part 1, the visionary renaissance.
Back in the 15th century, engineering really just began with these lone visionaries, and they were completely limited by the raw materials of their time. But if you think about it, what actually is an engineer? At its core, an engineer is a problem solver, a polymath who unites art, science, and mathematics to overcome human hurdles. And what's super fascinating to me is how this fundamental role remains exactly the same today. Whether you're building a medieval stone bridge or programming a satellite, you need an intense level of observation and just a relentless drive to construct a solution.
And when we talk about intense observation, there's absolutely no greater example than Leonardo da Vinci. Now, despite lacking any formal mathematical or scientific training at a university level, he used intense visual observation to basically dissect nature's mechanics. He was trying to wrest the very secrets from creation. He was a scientist of the visual world, conceptualizing machines that were almost unfathomable for the people of his era.
I mean, just look at what he came up with. Da Vinci conceptually invented a staggering array of devices: the parachute, a helicopter-like aerial screw, concentrated solar power, an armored fighting vehicle, and even the double hull for ships. But here is the magnificent, kind of tragic struggle of his life. His brilliant designs were literally centuries ahead of the robust materials he needed to actually build them. He had the vision, but the world just didn't yet have the manufacturing or the metallurgy to catch up.
All right, moving into Part 2, forging the modern world.
So let's accelerate into the 1800s. The Industrial Revolution finally provided the iron and steam needed for brute force physical builders to actually transform the landscape. Enter Isambard Kingdom Brunel. This guy was a Victorian giant of engineering. With just a robust, unyielding energy, Brunel boldly pushed the absolute limits of scale. He didn't just build things, he built the infrastructure that altered the lives of millions of people. But as we'll see, being a visionary builder of massive physical things comes with some pretty continual financial and engineering setbacks.
In rapid succession, Brunel completely revolutionized maritime travel. He built the SS Great Western, and then, crucially, the SS Great Britain in 1843. This is a massive turning point right here. The SS Great Britain was the very first modern ship. It was made of metal rather than wood, it was powered by an engine instead of wind, and driven by a propeller rather than a paddle wheel. It was a colossal leap forward for humanity.
But there was a real, immense human cost to Brunel's unyielding vision. He was historically celebrated upon his death, like this amazing quote from an 1859 newspaper praising his grand novelties so boldly imagined. Yet, while he was actually alive, his shareholders constantly balked at his ambition. His works were just too far ahead of their time to see immediate financial success. So he had the materials Da Vinci lacked, but he had to fight the brutal financial realities of scaling them up.
Now for Part 3, coding the lunar landing.
With the dawn of the space race in the mid-20th century, engineering kind of hit terminal velocity and transitioned into a brand new realm. We shifted from the tangible engineering of the 19th century, those colossal, thousands of tons iron steamships championed by Brunel, to a completely new paradigm, the literal weightlessness of software code punched into paper cards. Engineering was no longer just about manipulating iron and steam, it was manipulating logic and information itself. The very definition of the profession completely expanded.
And right at the forefront of this new realm was Margaret Hamilton. When she heard MIT was hiring programmers for the Apollo project, her immediate reaction was simply, wow, I've got to go there. She possessed this incredible drive and immediately realized the potential of what they were doing. In fact, Hamilton is actually credited with popularizing the entirely new term and discipline of software engineering, legitimizing it as a field every bit as rigorous as the mechanical engineering that built the actual rockets.
And honestly, thank goodness she did, because the crucial point is what happened on July 20, 1969. As the Apollo 11 lunar module was descending to the moon's surface, warning alarms suddenly flashed. A massive go, no-go decision hung in the balance. But Hamilton's team had designed a highly robust error-handling system. The software instantly recognized the error, interrupted and ignored low-priority tasks, and prioritized the critical landing functions. Her invisible code literally saved the lunar landing. How incredible is that?
Which brings us to part 4, the invisible revolution.
Hamilton's work kicked off an era where engineering rapidly shifted to this invisible digital world. When the National Academy of Engineering actually compiled the top 20 greatest engineering achievements of the 20th century, it resulted in a rapid-fire list of absolute marvels. We're talking electrification, the automobile, the airplane, safe water distribution, electronics, computers, and the internet. What was once the domain of lone geniuses sketching in notebooks had become a massive, global, interconnected effort that totally transformed the human experience. Let me ask you this directly, and take a quick second to actually count in your head. How many of these achievements have you already relied on today? Did you turn on a light, drink a glass of tap water, check your phone, maybe drive a car? You are literally standing on a mountain of cumulative engineering breakthroughs every single second of your day. Finally, Part 5, Shaping Tomorrow. Today, we are surrounded by highly specialized, incredibly interconnected wonders. Modern engineering encompasses an impossibly broad spectrum. On one end, you have engineers like Adrian Newey leveraging complex fluid dynamics to design motorsport vehicles that push the absolute limits of high-speed physics, and on the exact opposite end, you have bioengineers working at the microscopic level, creating life-saving technologies that operate right inside our own bloodstreams. Just look at these recent Queen Elizabeth Prize-winning marvels. They perfectly demonstrate how diverse fields cleanly deliver immense value to humanity. We have the Global Positioning System, which requires mind-bending orbital mechanics and atomic clocks. We have LED lighting, a massive triumph of material science that revolutionized global energy consumption. And controlled drug delivery, magically merging engineering with medicine. Each one of these builds directly on the principles laid down by engineers of the past.
So as we wrap up this explainer, I want to leave you with a bit of a challenge. Look around your room right now. Realize that practically everything you are touching, seeing, and using is the result of centuries of engineering lineage. It all traces back, from Da Vinci's impossible sketches to Brunel's iron giants to Hamilton's space-bound code. These invisible marvels are everywhere. So the only question left for us is, with the wild tools we have today, what on earth will the next generation of engineers build tomorrow?